If you heat up a gas and it expands, does all of your heat that you pour into the system go into making it hotter? Or does some of it go into pushing things around and doing work? This is the first law of thermodynamics. It's how we track exactly where all of the energy goes. And it's simply the conservation of energy, but applied to thermodynamic systems. Here's the equation. And I'll break down each part. So this is the first part. It represents the change in internal energy. So what's stored in your system. Q represents the heat that's added or released. And W represents work. So heat added to a system is either stored as internal energy or it's used to move things and do work on the environment. And this equation, the first law of thermodynamics, tracks all of it. I need to do some sign clarification before we move on to the first problem. So if you look at heat, it's positive if heat is flowing into the system. It's negative if heat is being released or leaving the system. Work is positive if your system is doing work on the surroundings. For example, a piston, you put in heat and it starts pushing things around. Work is positive, it's doing work on things. If work is done on your system, then work is negative. The change in internal energy is pretty straightforward. It's positive if it increases, and it's negative if it decreases. And in the equation that represents the first law of thermodynamics, why is work subtracted? It's because if you do work, it spends energy. So you can gain heat, but then you have to spend it on work. That's why it's minus. And here's some rules when it comes to increasing internal energy. If you raise the temperature, internal energy up. If you compress your gas, internal energy up if no heat escapes. And if temperature is kept constant, but the gas is allowed to expand, the heat expanding the gas goes into work. Does all work, not into raising temperature. So that's how internal energy works. Let's go through some problems. First problem. You have a pressurized air tank. This air tank, you add 3,100 joules of heat. And during this process, the gas inside that expands and pushes the piston does 2,200 joules of work. What is the change in internal energy? The first law of thermodynamics, and by the way, every formula for this topic is on the free cheat sheet in the description. It's heat added minus work done. Heat added was 3,100 and the work done was 2,200. This is 900 joules. So that means the internal energy of the system increased by 900. So you added your heat into the system and then some of it gets spent doing work. Left over inside is 900 joules. It increased by 900 joules from its initial internal energy before you added the heat. The rest gets used up doing mechanical work, pushing the piston. To wrap it up, the first law of thermodynamics tells us that nothing is lost, only shifted to a different form. So some heat becomes motion, some motion becomes heat. But every joule is accounted for.